11 kilometers per hour to reach in 47 minutes. We need to calculate the distance from Saurav's home to tuition. So here we know that from home, he goes to tuition by bus to reach in 27 minutes, traveling at a speed of 7 kilometers per hour. So the distance, what is the formula for distance?
Time into speed.
Time into speed. So we know that the time is 27 minutes and speed is 7 kilometers per hour. So what are we supposed to do to the time now?
Ma'am, we should convert it into hours.
Okay, so it will be 27 divided by 16, which will be around 0.45. Okay, so now you know the speed. So it is equal to 0.45 into 7, which will be around 3.15 kilometers. This is the distance from home to tuition. So please check if your answers are correct. The second sum is, what is the time spent by him in doing homework in minutes? So we know that Saurav spends an hour in drawing class and gets his homework and gets to his home at 11 kilometers per hour and everything, and then he does his homework for 3.5 hours. So we know that 3 hours means 3 into 60, which is 180 minutes plus 30 minutes, because 3.5. It's going to be 210. This is the answer. Then third one, what is the distance between his school and tuition? So we know that one minute, guys. Just give me 1 minute. Stylus is not working. Just give me a minute. School to tuition. So we know that school to home is there, and from home to tuition is there. So we know from home to tuition it is, what is the distance? It is 3.15 kilometers. So this is what we need to find. So from school to tuition. So from school, speed is again speed into time. So 47 minutes, we're converting into hours. So this 47 divided by 60, which is going to be 0.78. Now 0.78 into the speed, which will be 11 kilometers. It should be around 8.61. Now we're going to add it with 3.15. Plus 3.15, you will get around 11.76 kilometers in total. So please check if all your 3 answers are correct. Anybody who wants me to explain this again, please let me know. Check with your answers. I'll give you all 2 minutes.
Ma'am,
Ma'am,
cannot understand the decimal, ma'am.
the decimal. Okay. It's nothing. 27 minutes you're converting into hours by dividing 27 divided by 60. Okay. So we know that, okay, you want me to, 1 minute. This is how you will do it. Okay. So now you know that 27 is a small number. It is not divisible by 60. Am I right? Yes or no? Adya? Yeah, this is, yeah, please reply quickly. Okay. So you know it is not divisible because it's a small number. So what you will do, you need a 0 over here in order to divide. So in order to add a 0, you need a point. So you put a point. So now 60 watts are 270. We know that 60 into 4 is 240. That's the closest number. So 60 into 4 is 240. You divide and you subtract, it's going to be 30. Now you know that you can add another 0 because you've already put a decimal point. And 60 into 5 is 300 clearly. So 0.45 will be your answer. You got it, Adya? Is this clear? Adya, please respond.
Ma'am, now you can hear me, ma'am?
Yeah, I can. Is
Yes,
it clear?
ma'am. Yes, ma'am. We need to keep 0.45, right, ma'am?
Yes.
Okay.
So always remember when you're dividing, you know that you will take this table into what is 27. But it is not possible because 27 is a small number. So you need to make it a big number by adding a decimal. You can add only a 0. You can't add 4, 5 and all. You can add only a 0 and that is possible by putting a decimal. Okay. Now for example, you're taking 90 by 45. You know the decimal, it's not possible. So you need to add a 0. So you put a 0, you add a point. So 90, 5s are 450. So 0.5 will be the answer. This is how you will do the decimal. Am I clear?
Ma'am, what is the answer for number C?
11.76.
Oh, okay.
Okay. Any other doubts, anybody?
Ma'am, can you explain the C bit?
The C part. Okay. So we need to find the distance from the school to tuition. But you know that in between he's going to his house. You've already found in the first sum the distance between his house and the tuition. You need to find the distance from school to tuition. So distance between school to tuition is equals to distance between school to home plus distance between home to tuition. Okay, so A plus B is equal to the total. So this is what you already know. So 3.15, you'll keep it as it is. So this is what you need to find. So here it's already given that the speed is 11 km per hour and the time is 47 minutes. You know that the formula for distance is speed into time. Time you need to convert 47 minutes into hours. So 47 divided by 60, we will get 0.78. Okay. Now you need to multiply speed into time. So speed is 11. So 11 into 0.78, you will get around 8.61. This is the distance between home to tuition. So 8.61 plus 3.15 is equals to 11.76.
School to home, ma'am.
Yeah. Yeah, school to home only I said.
Okay, ma'am.
So you add 8.61 plus 3.15, it will be 11.76. Got it? Any other doubts?
No, ma'am.
Okay. So new chapter.
Light, shadow, and reflection.
Okay. Light, shadows, and reflection. So, what is light? Can anybody tell me?
Ma'am, light is a form of energy.
Very good. Light is the form of energy. Any other answer? Anybody else with a different answer? So, light. It is obviously a form of energy. So, this form of energy, what does it allow you to do?
It allows us to see.
Allows us to see. It allows sight, be able to see. So, this light, from where do you get this light? What is the source?
Ma'am, sun.
Very good. From the sun. This is the main source of light is the sun. Okay. So this light, it takes the light from the sun is able to reach your eyes, is able to reach your path. So light takes this quickest path. Okay. So it is point A and reaching your eye is point B. So it takes the quickest path between any 2 points. Therefore, light always travels in a straight line. Light doesn't travel like this. Travels only in a straight line. Okay, so another point to be noted. Okay, this ability or property of the light to travel in a straight line is known as
rectilinear propagation of light.
very good. So it's called as the rectilinear propagation of light. Okay, now how this is being proved? So there's an experiment to prove this. You take a candle, okay, and you're going to place 3 boards, okay, 3 cardboard boards. You're going to keep your eye here. Okay, you're going to keep your eye here. You're going to put a small hole in the same line. Okay, you will be able to see the light will pass straight through this and you will be able to see it. The light won't pass like this, like this, like this. So you know that it passes exactly same. So this experiment shows that light passes through a straight path. Okay, now let's learn about the 3 types of material. So objects. So objects are classified into 3 types. What are the 3 types?
And transparent, translucent, and opaque.
Very good. So objects can be classified as, this is something we already learned. Transparent,
Translucent,
translucent,
opaque.
and opaque. What is these 3 words?
When transparent means which we can see clearly and allows light to pass through it. And translucent means which allows light to pass through partially. And opaque object means doesn't allow any light to pass through it.
Very good. So transparent objects allow light to pass through it without getting scattered. So no light scattering. It's all in a straight line. Okay, give me an example.
Ma'am, a clear glass, water, air.
Very good. Water also, you can't say like it's completely transparent to you because what do you say? Still water, yes. If water is moving, then no. Okay. Then translucent, we know that it allows light to pass through it partially. So light passes partially. Okay. So give me an example.
And tissue paper, butter paper,
Very good. Tissue paper, butter paper.
colored glass.
Colored glass. Very good. Okay. Another we have opaque. So opaque objects do not allow light to pass through. Okay. Example.
Metals, metals,
Wood,
book.
body, everything, book and all. Yeah. Okay. So apart from translucent, transparent and opaque objects, we have another type of objects called as.
Luminous and non-luminous.
Yes, very good. That is luminous and non-luminous. Okay. So luminous. What does luminous mean?
When the yellow light, they give their own light.
Very good. So objects that emit light. So they emit light and okay, they are luminous objects. Example? Sun.
Candle.
All these are what someone said some other example. What is it?
Candle.
Candle emits light when we light it. It is not its own light. So luminous objects are objects that has light on its own. It doesn't need anybody to light it up. Those are luminous objects. Know the difference. Okay. Whereas non-luminous objects are objects that do not produce their own light, but then they reflect the light that is emitted by the luminous objects. Okay. So,
Ma'am, sun is a star, so you can write it.
sorry.
Ma'am, I think for luminous, there's another thing. I think it is the like the core of the earth, like that.
No, luminous means any object that emits lights on its own. It should not have any human activity or shouldn't be lit up by somebody. So the stars, the sun, or any planet that emits its own light. So those are only luminous objects. Now tell me, is moon a luminous object or non-luminous object?
Ma'am, it's a non-luminous object. Non-luminous.
How many of you all tell me it is non-luminous?
Ma'am,
Raise the hand, those who tell me it's non-luminous.
Ma'am, moon.
Yeah.
Ma'am, can you repeat?
How many of you all tell me that the moon is a non-luminous object? Okay. How many of you all tell me that the moon is a luminous object? It emits its own light. Okay, Soumya. Okay, Soumya, can you answer my question?
Yes, ma'am.
Can you tell me why do you think that the moon is a luminous object?
Ma'am, actually, the sun is the main provider because the sun, it has its own light.
Yeah, but
But
you told me that the moon is a luminous object. So if the sun is the provider, then how is the moon luminous object? Luminous objects are objects that has its own light. They do not reflect other people's light. But the moon is reflecting the light of the sun. So the moon is a non-luminous object. You're all right. Okay. So the moon cannot be considered as a luminous object because it doesn't have its own light. It reflects the light of the sun only. So a non-luminous object reflects the light emitted by the luminous object. Okay, so example, you have the moon, the earth. The earth is able to have light day and night because of the sun, because it reflects the sun. Okay, so these are the 5 types of objects. Okay, I'll just put it down because it's too clumsy.
next, should we write it?
Wait, I'll tell you when to write. Okay, yeah, you all can write it now. Tell me when you all are done and ask me if you all have any doubts.
Ma'am, how does Earth core get light?
How does Earth core?
Yes, ma'am.
The Earth core, you can say it's getting light because now if you take some gas, any a nitrogen gas or anything, or nitrogen or any, wait, let me to give you another better example. 1 minute. So there are some gases like nitrogen, then you have this helium. Okay, there are certain gases that under pressure, when you compress them or you apply a lot of pressure, try to compress them, they start emitting heat. Okay, and that heat will start producing some color. So now what, just take for example, you're taking a white sheet of paper, you're burning the white sheet of paper. What does the color turn into? Does the paper remain white? What
No,
color does it turn into?
black.
Black or brown. Similarly, the Earth's core, what is the temperature you think it is?
Ma'am, in millions.
Is it hot or cold?
Hot.
Hot. It's around 5,200 degrees Celsius. It's burning hot. Okay. So obviously, you know that fire is orange in color. So how is the flame getting light? The flame is getting light because that is how it is. Similarly, when something is super hot, it starts emitting fire. It starts emitting light because you know that fire emits light, right? So that is how the Earth's core is emitting light. So yes, you can tell that the Earth core is luminous or non-luminous.
Luminous.
Luminous because it has its own light.
Ma'am, mirror is what type of object?
Mirror, it's actually, a mirror is what? It's actually a type of liquid. Okay, that liquid only we're solidifying and we're making it into a mirror. So you can say that it is, okay, brilliant question. Now you all tell me, how many of y'all, wait, stop writing. How many of y'all tell me that a mirror is a luminous object? Raise your hand. Nobody.
What, ma'am?
A mirror is a luminous object. How many of y'all say yes?
And non-luminous means
Sorry?
luminous means and non-luminous means.
Don't I explain? No, luminous means objects that emit his own light. Non-luminous means objects that emits light from another source. Okay, how many of you tell me that a mirror is a non-luminous object? Okay, Shritesh, can you tell me why?
I think because it reflects whatever is shown in.
Exactly. That is the most simplest answer because it's already given you clearly that a non-luminous object is something that reflects the emitted light. So if a mirror is showing light, it means it's emitting light that is being reflected because whoever it is, can you please mute yourself? So a mirror itself is a reflective surface. So a mirror is a non-luminous object. Got it, Ashwath?
Ma'am, I am asking transparent, translucent or opaque.
It's opaque only, obviously. You can't see through, sorry, you can't see through a mirror. Can you see through a mirror? You can see
No,
only a
ma'am.
reflection. You can't see what is behind the mirror. So it is opaque.
Okay, ma'am.
It reflects with only mirror, ma'am.
Sorry? Come again. Please ask your doubts clearly, Da.
Ma'am.
Yes.
Ma'am, non-luminous means. Ma'am, non-luminous means it reflects with only mirror, ma'am.
No. Non-luminous means it reflects the light of the luminous. That is only non-luminous. It's not only mirror. You know that the earth, we are having day. Why? We're having day. Our day is bright because of the sun, right? The sun is only making the earth bright. So the earth is reflecting the light of the sun. So the earth is a non-luminous object. You have so many examples for non-luminous object. It's not only a mirror. Got it?
Ma'am, I have a question. So, is a torchlight a luminous object?
Torchlight is working because you're putting battery. No, it doesn't have its own light.
Oh, okay.
Yeah. But you can actually consider it luminous because you cannot consider it non-luminous. Tell me why. Anybody? Why are you considering a torchlight?
Ma'am, because it's not reflecting any light by another luminous
Exactly,
one.
exactly. So another easy way to find out if an object is luminous is just see if it's reflecting or not. If it's not reflecting, then you will put it under non-luminous category. Sorry, luminous category. And it should emit light.
Ma'am, in which speed does light travel? What speed?
Sorry?
In what speed does light travel?
We will actually be looking at that in the further this thing, but it's almost like it's super fast. Okay, it almost covers how many units do I say? I'll just write it down.
And covers
And
like 300,000 kilometers.
Almost that's it's like 299,792,458. So once 10 hundreds, thousand, then there's a lakh, 10 lakh crore, 10 crore. So 29 crore, 97 lakh, 92,458 meter per second. So these many meters it covers per second. That's how fast light travels. So light is like the fastest on Earth. Like nothing else travels more faster than light.
Ma'am, can you kind of scroll down? Yes, ma'am.
Ma'am, this is Adrit. I'm done.
Okay.
Ma'am, this is Deepika. I'm done.
Okay.
Ma'am, this is Sritej and done.
Ma'am, I completed. Ma'am, I'm Adya completed.
Okay.
Ma'am, I didn't hear you properly. What did you say?
For the
No, for the question.
which question?
Because like everybody is saying done.
No, I just asked. No, I didn't ask anything. It's a regular thing. Once you're done writing everything, you're supposed to tell me that you're done.
Okay.
So that I can go to the next topic. Are you done?
Yes, ma'am.
Okay. Who else is left? Can you just tell me who else is left? All of you are done?
Yes, ma'am.
And I'm writing the
Yeah. Okay.
proportion of light.
Tell me when you're done.
Ma'am, the speed of light per minute is 1 crore 11 lakh.
Yeah.
Yeah, meters per.
Yeah.
Ma'am, I'm done. Ma'am, I'm done actually.
Okay. All right. Okay. So now we know that these are the different types of objects. So now if this is light, let's go to the second part of our chapter, that is the shadows. What do you think a shadow is?
Ma'am, shadow is a dark outline of a opaque body.
Okay. Anybody else?
It is always dark.
Okay. So when does the shadow form?
Ma'am, when it's blocking light.
What is blocking light?
Ma'am,
When
when
an
light
object
is
comes
obstructed.
between the source of light.
One person at a time.
Ma'am, can I tell?
Yeah.
Ma'am, when light is obstructed by an object, shadows.
So it can be any object. Can it be any
No.
object?
Opaque object which blocks light.
So it should be an opaque object, not just any object. Yeah. So shadow is formed when an opaque object comes in the path of light. Okay. So a shadow needs a screen. It cannot, for example, you're flying in the air. Okay. So you have an opaque object and there is sunlight. So this is happening in the air. So it's all air. So the shadow cannot be formed in the air. So in order for the shadow to be formed, you need
Screen.
a screen or a platform. Only then
Or a flat surface.
you will get a shadow. But in air, you will not get a shadow. Okay. So a shadow needs a screen where it can be formed, like a ground or wall or a room or something. So this shadow will give us, so with this shadow, no, I'm not showing you the object, but I'm showing you only the shadow. So by looking at the shadow, what are the properties that you can find about the object?
Ma'am, source of light, opaque body and a screen.
No. What I'm asking you is, now I'm just taking an object. Now I'm just showing you the shadow of the object, but I'm not showing you the object. So by just looking at the shadow, what can you understand about the object?
Ma'am, shape.
Very good. The shape.
Size.
Anything? Height. Height?
Ma'am,
No.
ma'am, no, because like sometimes the shadow can be different sizes by the
Exactly.
light.
So the shape
Ma'am?
is the only thing that you can actually find. Nothing else. So shadows gives us an idea about the shape of the different objects. Also, sometimes it can be. So sometimes this is not always right. So sometimes,
Ma'am, I think when shadows more darker, the light is powerful.
sorry, come again.
When the shadows more darker, it means like the light is more powerful.
That happens in most of the cases, but not all the time. Okay. So shadow gives us an idea about the shapes of different objects, but it is not accurate all the time. So it can sometimes be misleading about the shape. Okay, like the shape of the cone, like for having an ice cream cone. Okay, so you know that the cone, this is what a cone, but in the shadow, you will see only a triangle. So this is a 3D object, this is a 2D object. So the shapes can be misleading. Okay, it cannot give you all the time the accurate shape. Okay, so please note down shadows. Any doubts, guys? Okay.
Ma'am, I completed.
Okay.
Ma'am, I'm done, Aishwarya.
Okay.
Ma'am, I'm done, Deepika.
Okay.
Ma'am, I'm done, Sritej.
Okay.
Ma'am, I'm Adya. Done.
Okay. Who else is left?
Ma'am,
Ma'am, this is
Adya.
done.
Done.
Okay. Anybody left?
Ma'am,
Okay, Ashwath, just tell me when you're done. Okay. Are you done, Ashwath? Ashwath,
yes,
are you done?
yes.
Okay. Now, guys, we're going to see a new concept which is called as a pinhole camera. So this is a camera that you can make at home, and I will not be giving notes on this. So please listen to the video very carefully. I'll play it twice. So once you can just see the video for listening carefully. The second time you can see it for writing notes. Okay. This is an important concept.
Have
Ma'am,
you
Please
it
listen
ever
makes
seen
us
carefully.
see
light
concepts of
rays coming?
Yes. So just first understand it, then I'll explain.
Have you ever seen light rays coming through the holes of a damaged roof? You'll be surprised to know, as you can see, that the light rays from such holes produce images of the sun when they fall on the ground. Why? Because these irregular shaped holes in the roof act as pinhole cameras. Now, what are pinhole cameras? Let's first construct one pinhole camera and then let's try to understand the principle. Now, by definition, a pinhole camera is a simple optical device that forms an image without using a lens or a mirror. That's surprising. Now, let's join two hollow cylindrical boxes of different diameters in such a way that one box can just slide within the other. Now, what do? We make a small hole in the larger cylinder there and also make two holes in the smaller cylinder, the one inside. Fine? But there is one care you need to take. The inner hole has to be rectangular and the outer hole has to be circular. We now fix a translucent paper, say a tracing paper, on the rectangular hole because that's going to act as a screen. Now, very importantly, These two cylinders must be enclosed so that you can prevent light from entering the larger cylinder. That will mess up our image. Now, use this pinhole camera and try looking at a tree. Surprise! A clear image of this tree can be obtained on the screen if you slide the smaller cylinder back and forth. Now, how exactly did it happen? Let's look at this diagram. The tree is, say, MN. M is the topmost point, N is the bottommost point. The light rays coming from the bottom of the tree, that is N, they pass through the small hole and strike the screen at the top of the axis, N dash. Can you see that? And the light rays coming from the top of the tree, that is M, strike at the bottom of the axis, that is M dash. Now what happens as a result? As you can see, an inverted and also a much smaller image of the tree is what you get on the tracing paper. Remember the tracing paper which acted as a screen? Now the size and contrast of this image, it can be adjusted. For that, all you need to do is slide the smaller cylinder. Also, one more thing, the image depends on the size of the pinhole. The smaller the pinhole, the sharper will be the image, and of course, vice versa.
Okay, I hope it is clear to all of y'all. Did y'all get an idea of what a pinhole camera is?
Yes,
ma'am.
ma'am.
Okay, so now
Ma'am,
for
the
demo.
volume was low.
Sorry.
Ma'am, the volume was low.
Okay. I've actually kept it at the maximum. Was it low to everybody?
Yes, ma'am.
Okay. I don't think I can do anything with the audio. I'm really sorry, guys. But you can use the captions. Okay, you can listen to the. I've turned on the captions for all of y'all, so you can read the captions. I'm gonna replay it again. So now you can watch it again for noting down definitions and everything. Okay.
Have you ever seen light rays coming through the holes of a damaged roof? You'll be surprised to know, as you can see, that the light rays
Or
from
wait,
such
well, I'll do something. 1 minute. Is it very low, guys?
No, ma'am. Ma'am, not as much. It's very low.
It's very low. Okay, I'll maybe play the audio in my phone. Maybe that should help. And you can watch the video.
Have you ever seen light rays coming through the holes of a damaged roof? You'll be surprised to know, as you can see, that the light rays from such holes produce images of the sun when they fall on the ground. Why? Because these irregular shaped holes in the roof act as pinhole cameras. Now, what are pinhole cameras? Let's first construct one pinhole camera and then let's try to understand the principle. Now, by definition, a pinhole camera is a simple optical device that forms an image without using a lens or a mirror. That's surprising. Now,
Ma'am, it
let's
is
join
low.
two hollow cylindrical boxes of different diameter.
Sorry?
It is low, ma'am. Voice.
Is it still low for everybody?
Yes, ma'am.
Wait,
Yes, ma'am.
1 minute. I'm sorry, guys. I don't think I can do anything. You can look at the captions. That's the only way, I guess. Wait, see if you can listen now.
In such a way That one
Is it
box
still the
can
same?
just slide within the other. Now what do we do?
Is it still the
Yes,
same?
ma'am. Yes, ma'am.
No guys, I can't do anything. I'm really sorry. I don't think there's any other way.
Ma'am, you can share the video in the WhatsApp. We will see.
Yeah, I'll do that. I'll do that after class. But for now, just look at the captions and note down the points that they're saying.
We make a small hole in the larger cylinder there, and also make two holes in the smaller cylinder, the one inside. Fine? But there is one care you need to take. The inner hole has to be rectangular and the outer hole has to be circular. We now fix a translucent paper, say a tracing paper, on the rectangular hole because that's going to act as a screen. Now, very importantly, these two cylinders must be enclosed so that you can prevent light from entering the larger cylinder. That will mess up our image. Now, use this pinhole camera and try looking at a tree. Surprise! A clear image of this tree can be obtained on the screen if you slide the smaller cylinder back and forth. Now, how exactly did it happen? Let's look at this diagram. The tree is, say, MN. M is the topmost point, N is the bottommost point. The light rays coming from the bottom of the tree, that is N, they pass through the small hole and strike the screen at the top of the axis, N dash. Can you see that? And the light rays coming from the top of the tree, that is M, strike at the bottom of the axis, that is M dash. Now what happens as a result? As you can see, an inverted and also a much smaller image of the tree is what you get on the tracing paper. Remember the tracing paper which acted as a screen? Now the size and contrast of this image, it can be adjusted. For that, all you need to do is slide the smaller cylinder. Also, one more thing. The image depends on the size of the pinhole. The smaller the pinhole, the sharper will be the image. And of course, vice versa.
Ma'am, what is the homework?
Wait,
In this
I'll tell you.
video, I'm going to
So the homework will be explain the functioning of a pinhole camera. Okay, write it in your own words and bring it.
Ma'am, project like thing. You
No,
can.
no, no. No need project and all. That's going to take some time. Just write the working of or the functioning of a pinhole camera. How it functions. How are you able to see the image? I want to know.
Okay, ma'am.
Note it down and you can leave once you're done.
Bye, ma'am.
Bye bye.
Ma'am, I completed. Can I leave?
Yeah, done again. Bye.
Thank you, ma'am. Bye, ma'am.
Bye.
Bye, ma'am.
Bye.
Bye, ma'am. Thank you, ma'am.
Bye. Thank you.
Bye, ma'am.
Bye.